This video talks about the dot product of two vectors and also finding the angle between two vectors, which is the primary application of the dot product for us. Now let's say you have two vectors in component form. The dot product says you take the first component of both and you multiply them, 3 times 2. Then you add it to the product of the second component. Negative 1 times 4. So we get 6 plus negative 4, which is 2. Okay. Well, that's going to be a component of this equation that relates alpha, the angle between these two vectors, to the vectors A and B. Now, before I get started showing you why this is true, cosine of alpha equals A dot B over the magnitude of A times the magnitude of B, let's just sort of clarify what these things are. So if I had A dot B, remember that's first component of that, first component of that. So we have A1 B1 plus A2 B2. Then think about how you'd go about thinking about the magnitude of A. So the magnitude of A is the length of that vector, and so if that distance is A1 and that distance is A2, then the magnitude of A squared is equal to A1 squared plus A2 squared, and then the magnitude of B squared is B1 squared plus B2 squared. Okay, so that's sort of background thinking about these things. Let's think about how we know this equation is true. Have you ever stopped to think that the way we come up with any equation is we think about the same thing in two different ways? Here we'll think about the length of this line in two different ways. The first way we'll think about it is by the law of cosines. The law of cosines says this side squared, okay? So if you were going to think about it, this side would be C, and C squared, okay? So you could pencil in C squared is equal to, but we're not going to use that. We're just going to think about another way of measuring that. It's equal to the magnitude of A squared plus the magnitude of B squared minus 2 times the magnitude of A times the magnitude of B times cosine alpha. Another way of thinking about this is using the distance equation. Now the distance equation would calculate, say, C here, or you could call it D. But the first thing that would happen would you have a square root. So how do you calculate this distance squared? Well, it's A1 minus B1 squared plus A2 minus B2 squared. You could sort of think about that being this triangle right here. That distance is A1 minus B1. That distance is A2 minus B2. So A1 minus B1 squared plus A2 minus B2 squared is that side squared. Okay, so now we have an equation, right? We have that piece. Let me think about what all of those components are. Well, we agreed that this up here was A1 squared plus A2 squared. Magnitude of B squared is B1 squared plus B2 squared minus 2 magnitude of A times magnitude of B cosine alpha. If I'm going to multiply this times itself, A1 minus B1 times A1 minus B1 is A1 squared minus 2 A1 B1 plus B1 squared. Check and make sure you believe that. Then squaring this one gives me A2 squared minus 2 A2 B2 plus B2 squared. Okay. So now a bunch of stuff cancels, luckily. Both sides have an A1 squared, both sides have an A2 squared, both sides have a B1 squared, both sides have a B2 squared. That makes life a lot better for us. We have negative 2 magnitude of A, magnitude of B, cosine of alpha equals negative 2 A1 B1 negative 2 A2 B2. Looks like we have a lot of negative 2's. Let's divide by negative 2. I get magnitude of A times magnitude of B equals cosine times cosine of alpha equals A1 B1 plus A2 B2. Now hold on a second. A1 B1 plus A2 B2, that's just A dot B. So if you get cosine alpha on a side by itself, this is A dot B, and then we divide by that to get cosine alpha by itself. And indeed, we have exactly that formula right there. Now, let's just finish this off by using that formula once. Let's find the angle between these two vectors. Oops, that has a little typo. Between the vector A, and let's call this the vector B. Okay? So, what's the angle between them? Well, I'm going to calculate that angle by thinking about cosine of alpha equals A dot B, so that's what, 3 times 2 plus negative 1 times 4 over the magnitude of A, so that's 3 squared plus negative 1 squared times the magnitude of B, which is square root of 2 squared plus 4 squared. Okay, so what do we have there? We have cosine of alpha equals 6 minus 4, so 2 over the square root of 10 times the square root of 20. Okay, that might be able to simplify a little bit, but we'll just put that on pause for the moment. Now, cosine inverse is what I'm going to need to solve this, right? Cosine inverse. What do I know about cosine inverse? Cosine inverse assumes that my alpha is between 0 and 180. So I'm always going to get a positive angle between these. So pictorially, you're never going to get sort of this angle out here. You're going to get a positive angle less than 180. Less than or equal to 180, I should say. 2 root 10 root 20. So what's that going to come out to? Well, so cosine inverse of 2 divided by the quantity square root of 10 times square root of 20 gives me an angle of approximately 81.9 degrees.